So we're going to move on to the next person or the next group in our effort here. So Bernhard, Alexey, and Dmitry, Fluence Labs. I have two. Well, I've got Anna too. Okay, cool. Well, we're just going to hand Fluence the microphone here and let them do their thing. Off-chain purposes. You guys ready?
Yeah, ready.
All right, take it away.
Hi, folks. Thank you for coming on Fluence's ETH Denver workshop. My name is Dmitry, and almost the whole team is here. Nice. So, what we are going to cover today? First of all, I will make a short overview of what is Fluence, what problems could be solved with it, and what skills it requires. Then we will discuss the boundaries and how to approach them. And finally, I will share the resources, how to learn more about Fluence, how to start, what is the best way to begin hacking. So first of all, what is Fluence? Fluence is the network and protocol. It enables open applications. It's a new concept that requires detaching ownership of the application of services from authorship. It will have its own chain, but it doesn't yet. And what's most important right now is that it can complement blockchains with off-chain computations. Fluence is all about distributed composition. So it has off-chain computations and state, and you can access external resources like APIs, file storages, full nodes of different chains, or demonized processes on the local machine where the Fluence node is running. So it's open to the external world. These capabilities are provided with the help of WebAssembly, with WebAssembly modules, which are bundled into services. Service is the main building block of the computations. These service capabilities can be composed in this open distributed network, and this composition is expressed with the Fluence's special language, Ecomarine, which is driven on the client side. So execution of the function of the service looks like this. This is a one call instruction. So what we have there, we have the instruction, we have the location where the code will be executed. It's an identifier of the peer. Then we have a service which has different functions. Service is a WebAssembly code. We state the function. We have a list of arguments, and we can assign a name to the output. It could be more complex. So in this snippet, we make two blocks of sequential calls. So first, we do a call for filter change on an Ethereum node. Then we go to a node to which the client is connected, and then we provide the data from Ethereum node to the client. So it's a request-response pattern expressed there with Ecomarine. Actually, Ecomarine scripts could be much more complex. You can handle errors, make iterations, do parallel computations, and so on. But it starts with these simple instructions. And yep, Ecomarine is based on p-calculus, full-featured p-calculus with parts of lambda calculus. So finally, about the technologies. Fluence, to approach Fluence, we have two surfaces. You can make a service, or you can make an application, make a composition of different services. Services are compiled to WebAssembly, and Rust language is the best choice for WebAssembly. We run this WebAssembly code with the Fluence Compute Engine, and we have a wonderful Rust SDK to aid developers and hackers to start as fast as possible. And then you can use a composition on client. It's done with JavaScript. We have a Fluence JavaScript SDK. Actually, it's a TypeScript, but you can use it from JavaScript as well. And to express this composition, you need to use EchoMarine. That's what was on the previous slides. It's called EchoMarine Intermediate Representation. It's the language for composition. And probably nobody knows it. So we have a thorough documentation about EchoMarine. That was the short technical intro, and now I want to ask Bernhard to tell about the bounties.
Okay, for the bounties, we fundamentally get two tracks, an application track and an enabler track for a total of $6,000. And the application track is really geared towards building decentralized apps and in our case, actually decentralized services. Could be around oracles, relays, or actually processing algorithms for data streams. So in the context of a smart contract, we believe Fluence could be a really, really great off-chain complement. And one example would be in the Oracle space, where we could pull price pairs and related data from various DEXs, possibly even across blockchains, and implement the necessary data processing algorithm. I mean, you have to get from the inputs to the Oracle, the truth at a particular point in time. And to get there, you need data processing, data transformation. So for example, the sliding window averages are one way of doing that. And this could be a set of interesting services where the data processing algorithms themselves could be each one a service that then could be composed in runtime, even depending on the data feed user requirements. So you compose these services then into an application, and that really allows the data feed recipient to select the inputs, a DEX, blockchains, for example, are inputs, and the actual data processing algorithm. As a bonus, we would be really, really cool if a team could tackle the issue of trust and reputation with respect to service components, but also actual algorithms. And it's actually not, it's not that hard, but it's super interesting because that you start getting a trust and reputation dependency graph, and this would be something we'd really, really would be super happy to see. Our other track is the Web3 Enabler track, and that's really geared towards seeding the Fluence Web3 ecosystem. We don't have, let me just step back. The underlying technology is WASM, and in particular WASI. And it's fairly early in the development, even though everything's maturing rather quickly, but it is early. So there is no Web3 library like Ether.js or Ethers or Web3 Pi available today. And JSON RPC is what rules. And in this track, we'd be really interested in seeing people implementing type systems, especially around Ethereum, type systems, codecs, RPLs, as composable and reusable services. So instead of, if you want to think it from a repo perspective, instead of having one repo with all the components for a Web3 library or development kit, you actually could start composing the equivalent of that repo on the network. And if you're really ambitious, you could look at several Web3 SDKs that could, I think, were close to being easily ported. Not without any work, but it's doable because there's a lot of WASM support already. And if you do decide to do that, I mean, first of all, reach out. We're super happy to help you. But start thinking about it as a repo, as a distributed repo, really. And how you break down the service granularity matters to a certain extent, even though I think best practices for microservices could really help in making those decisions. And again, reach out. We're super interested in helping you on this and succeeding. Reusability, obviously the entire system is built in reusability. And as Dmitry pointed out earlier, the Fluence tech stack, the runtime, and the composition tools are going to be supplemented by or augmented by a blockchain, where the blockchain, among other things, holds licenses to your services, subscription licenses. So if you build a component and you attach a component to a license on the blockchain, then other users, developers, can reuse that component, subscribe to the license, get permissions to your component, and start building. So you really should keep that in mind, because you're not only eligible for prizes right now for the hackathon, but there's a pretty interesting monetization track for you and for the work you're doing once the blockchain is up and running, because obviously the services you develop today are fully eligible to be subscription licensed on the blockchain. So keep that in mind. So reusability is really big deal, and composability, because that's really what drives the definition and the value of your components in a composable system. It should be fundamentally useful. It really should. I mean, it shouldn't be a toy example. It should be something that's needed, that's useful, and that's be used by other people. And eventually, this obviously the usefulness could be measured by simply the license subscription volume on the blockchain. And finally, if I've given you examples, but those are open tracks, and if you want to integrate with other projects, whether it be on the file side, IPFS, Filecoin, any one of them, if you're interested in integrating with a security layer or a decentralized key management solution like NewCipher, for example, would be absolutely welcome, and please reach out. And that was it on the bounty side. If you have any questions, just please get them to us. We have many resources available, Discord channel. We have a Calendly link that's somewhere that you can set up calls. So we're here to help you for the next week. Have fun.
Thank you, Bernhard. I will make a short overview of the main resources to start with if you want to hack on Fluence. So first of all, it's Fluence Labs GitHub organization, and we have a few repositories pinned there. It's a Fluence repository, the main one with the node implementation. It's EchoMarine with implementation of the language, of the composition language, and its interpreter. It's Fluence Compute Engine for running modules and linking them together to make services. It's RFCs with high-level documentation of the paper. And we also have two special repos that I will cover a little bit later. You're very welcome to raise any questions in the Fluence discussions in the main repository. If we face recurrent questions, we'll move it there. And if you ask any questions there, we will definitely answer it, and it will be visible and helpful for anybody. We have a dedicated ETH Denver-hackathon repository. Bernhard will probably cover it a little bit more after the presentation. It's in ETH Denver-hackathon repo. It has code examples and tutorials and links to all the required resources. So take a look on it. Then we have a Fluent-pad example project It's quite a sophisticated project with CRDT text editing capabilities. And the repo contains both backend on Rust and front-end on TypeScript and React. So take a look on it. The main source of knowledge about the Fluence network is the documentation portal, fluence.dev. We have tutorials and reference documentation for each part of the Fluence stack there. And finally, during the hackathon, we will be on Discord for sure. So join there, ask questions, shout anything. It would be nice. And we have slots on Calendly. So if you want to brainstorm your idea or figure out the right design for the components and so on, please book a time and let's discuss it. That's all on my side. Bernhard, can you share the code?
Yep, it's up. Okay, as Dmitry pointed out, this is the repo reflection we have on GitHub, and the idea really is to illustrate how to use the technology in a very stylized educational manner on doing Web3 services and service calls. And for this, we need two modules. One is a curl adapter. Curl is our transport of choice. That's how it is within the WASM environment. And we have another module I call Facade, which basically contains all the code and functions for the things we need to do to interact with Ethereum. So how do we interact with Ethereum? Well, it's actually at the JSON RPC level. So Ethereum has a very well documented JSON RPC, and that defines basically the underlying structure of pretty much every SDK, Web3 library or SDK you're using. So this is the level we're getting in from right now. And obviously, as part of the hackathon, we really would like to see it to make some progress on abstracting over that lower level. So what do we need to do? We need curl. And let me actually go back to curl first. So there are different ways of using services in the system. If there was a curl service available on the network already, you could subscribe to that as part of your development process and integrate it this way. In our case, because it should be educational, we put it all together, and you actually use curl as a WASM import module. And it's pretty straightforward if you've done WASM, and the entry point into WASM is through a main function. It's not through a lib function. It's through a main. And so it's cargo new default, which is really important. Oh, by the way, we're talking Rust here. It's just in case. And that gives you your curl command. And it's pretty simple. Just the way curl works, it's your string, because we're not working in shell. We're just going straight to the sysline, and so you can't really give you a list of arguments. It has to be a string, and that's pretty much all there's to it to include a curl adapter into your project. So going back to some very fundamental, so get balance, which is, it basically gives you a count balance on a particular chain, where the chain is obviously defined by your URL. And first we need our curl request function. And then we got a few utilities. We can go over those, and your results, we definitely go over those. And but what's most important is Fluence. From Fluence, we import the Fluence compute environment portion of the crate, and that really gives us a macro that transforms or augments each of your functions into runtime compatible code snippets. So if you And Alexey, anytime you want to pitch in, do it, right? Just don't be shy. So if we ask get balance, so it's a very simple, it's a very well defined JSON RPC call, and the method name in the JSON RPC API is fGetBalance. We also want to get a nonce, which is really the ID in the parameterization. And anybody who's ever worked with Ethereum smart contracts, Web3 SDKs and libraries, you know that managing the nonce is the ID is a huge deal, or can be. And what we've done in this case, if you go into the utilities, you see that we we automated the nonce counter as a thread safe incrementer, and that really takes care of it, as long as you obviously stay within that application space. Once you move out, you have to start accounting for the nonces yourself. The response from JSON RPC is obviously a JSON string, which is well defined for each of one of these calls in the Ethereum JSON RPC. And you then get it, which you get back, you get the response back, and you start processing the response. Now, one of the tricks right now, and we are working heavily on changing this, but one of the tricks right now is you can't return the standard result to argument structure in your function within the FCE marked up functions. So what you have to do is you have to build your own. And here it's in FCE results. And what you're basically doing is you build your own result as a single variable type structure. And the way we're doing it, we're going from result string, and we're implementing it for our own OK and for our own error. So basically, result either is OK or it's error. And in this case, the discriminant actually is the error string. You can do it whichever way you want, but I find it pretty simple, and I actually remember without having to look at my own stuff. And so basically, if you return an OK, a good result, your error string is empty. And if it's not, then you return your error message. And that's a very easy match discriminant to determine what your result outcome is. Okay, so that's what you really get back. And then we have a utility function, check response string, that basically checks that the response, hang on, we'll just go to it, basically here, that really determines the discriminant with respect to a successful or error-prone result. And you get this back.
Can I add something?
Yes,
Can you
go ahead.
zoom a little bit so it's clearer? Yeah, can you enlarge the text? Yeah. Great, awesome. And regarding the result here, the thing is that if a function is marked as FC, it's available to call from outside. And in order for this to work, the serialization should work. And that requires every structure that's returned from FC function to be also marked as FC. That's why Bernhard had to implement the JSON RPC result here. Yeah, for example, if Bernhard would kindly scroll down, we would see their transaction structure all the way down. Yeah, this is the first one. That's the one that works with the serialization. So it's an easy way to deserialize all the fields at once from JSON RPC call. Yeah, and also there is a TX structure that's marked with FC. It's a little bit upper. Sorry for making you scroll in. Yeah.
That's an easy task. I can scroll anytime.
Nice. So this structure is marked as FC, so it's automatically serialized and can be used inside Akumarin code, the scripts that Dmitry was showing. So you can access any field right in the script. No need to wait for it on the client and parse. It's already available in the script through JSON path. You can look that up in our documentation, hopefully. Yeah, and the way it's used below, you can see that there is a get filter changes function below. Hopefully, or well, this one. No. The function down below, the last one. Can you scroll? Yeah, this one. This one batches JSON RPC requests and returns a vector of transactions, and you can iterate on this vector right in the script. So, for example, you can get TX hashes from somewhere from another RPC call in the script and compose it with get TX by hashes. So it all happens in the one script, in one request. No need to wait for a round trip. It's like batching, but better. It's composing. And you can start processing those transactions right in the script. And, for example, send different requests to different services. You write different oracles or anything you can imagine to process those transactions. You can you can manipulate the network to your needs, and standing on the information you see in the transaction, you can send requests there or there and route them any way you want. Yeah, that's regarding the FC structures. That's it.
Okay.
Later.
We got 4 minutes. I don't know, Dmitry, do you want to like close it out, or are there any questions from anybody?
I think questions would be nice, and if we haven't any, maybe you can show the front-end part as well, especially the use of Aquamarine.
I can do that, Bernhard.
Okay.
I can do that. I hope it will work.
I'll stop sharing, and then it's all yours.
Yeah. So we have this simple front-end application in ETH Denver-hackathon repository that basically shows the transactions that are taken through polling from some ETH node, some Ethereum node, and it works very, very simple. It uses set interval to update data periodically, and on every update it queries transactions that are new pending transactions from the Ethereum node, and then it simply displays it through React means. What's done here could be even further simplified by using the script storage API that every node in the network has. It allows you to automate this polling thing and to avoid running the front end for that. So you can just say, node, please periodically, like cron, on every given interval, run this function and send results somewhere to the client, to another service, anywhere you want on the network. The API is pretty simple. It looks like this. So you just send a call to your relay that says add this script, and you provide another air script, for example, like this one, there, and it will work. You can also specify the custom interval as a second argument. It has to be in the quotes, meaning it's a string, even though it's a number. Just keep that in mind, because it's, yeah. And you can remove it if you want. And you can also order a node to list existing scripts and see what others have run, and what, if you have run anything, you can see your script here. Yeah, and another thing, if you don't specify an interval, it will run just once. that's useful for writing scripts in background.
Okay, cool. All right, just let me know. Thanks, guys. We really appreciate the presentation.
Thank you.
So for anybody that wants to come and learn more about Fluence, make sure that you head over to their table during the virtual event later this afternoon. Make sure you collect their NFT. They've got some things that they'll probably have you do for that. And yeah, they've got some really interesting bounties to work on. So engage them. These guys have got a lot of things to offer, and we really appreciate the opportunity to work with them. So thanks, guys.
Thanks for having us. Have a great one.